Alright, in this video I want to go over number 5 on our friction problem practice problems. That is, during a football workout, two linemen are pushing the coach on the sled. The combined mass of the sled and the coach is 300 kilograms. The coefficient of friction between the sled and the grass is 0.8. The sled accelerates at a rate of 0.5 meters per second squared. Determine the force applied to the sled by the lineman. In this problem, we want to start with a free body diagram. And with the free body diagram, we will start with a dot that represents the sled. We have a force of gravity going down. We have a normal force that goes up. In this case, the normal force and the force of gravity are equal to each other. We know that because the sled is being pushed and the sled is not jumping up into the air or falling through the ground. If we look at the question itself, the combined mass of the sled and the coach is mass is equal to 300 kilograms. The coefficient of friction between the sled and the grass is mu is equal to 0.8. The sled accelerates and is an acceleration of 0.5 meters per second squared. Determine the force applied, force APP, on the sled by the lineman. So, if we're going back to our free body diagram, we know that we are solving for some force applied, and that'll be a question mark. And if that's the case, we will probably have a force of friction. That is also something to be found out. Nowhere in this question do we see the keyword constant speed, so we don't know that the left or the right arrows are equivalent. One place we can start is we know the equation for the force of gravity. The force exerted by gravity is equal to mass times the acceleration due to gravity. In that case, we know that G is equal to, and rounded to, 10 meters per second squared. So plugging in what we do know, F of G is equal to 300 kg times 10 meters per second squared. That gives us 3,000 newtons. Fg is equal to 3,000 newtons. If we look at our free body diagram, we have an equivalency line saying that the force of gravity is equal to the normal force, which is 3,000 newtons. To go from there, we go back into our givens. We've used mass. We haven't used coefficient of friction. We can go there. Let's try to use the coefficient of friction. If that is something we might use, we'll put down the equation of coefficient of friction is actually equal to the force of friction divided by the normal force. Once we see this equation, we know that one of the things we need to find out is the force of friction. We know the normal force, and we know the coefficient of friction. So, one of our other equations is just this manipulated. Force of friction is equal to the coefficient of friction times the normal force. Oh, I have an extra F there. Plugging that in, we get 0.8 times 3,000 newtons gives us a frictional force of 2,400 newtons. Let's plug that in, 2,400 newtons. We can't go ahead and say that is equal to the force applied because nowhere in our question was there a constant velocity. But we can go back in our givens. We haven't used acceleration, and we know if there's an acceleration, that means there's also going to be a net force. And we know Newton's second law is F net, the net force is equal to mass times acceleration. And in that case, we get 300 kilograms times 0.5 meters per second squared. We get a net force of 150 newtons. That net force of 150 newtons means that the difference between the F applied and the force of friction is 150 newtons. The F applied is more, and we're accelerating to the right. So in order to get F applied, we can add together the net force and the force of friction. So we get 2,400 plus 150 newtons gives us an answer of 2,550 newtons as our force applied by the two linemen.